Good morning, guys. It's grade 9 today. Inshallah, we're going to continue lesson 2 of chapter 18. We'll talk about telescopes. So, yesterday we just explained the telescopes, okay, or the referent or the optical telescope, which means the telescope that bend on light or they collect the light or visible light radiations and just start to form an image for the further objects or celestial bodies in the space. And we know the difference between refracting telescope and reflecting telescope and how they work and so on. And we stopped at the point that the scientists figure out that most radiations and the most of the light is deflected or somehow is scattered because of the atmosphere particles, which make it the pictures or the images of these objects in space is not that clear. That's why they try to manage, okay, or they try to put their telescopes up of mountains or high elevations to try to avoid the thick column of the atmosphere, and also or later they think if they are able to send telescopes to the space. Okay, so actually, once science they thought to put telescopes in the space, they got per idea or more per idea. What the idea here? Okay, actually, there was a scientist. His name is Kirk Maxwell. Maxwell figured out that the spectrum, okay, or the light, is just a small part of the total radiations that are emitted from the celestial bodies or from stars and sun and so on. So that means there is another radiations are combined with the light. Yes, actually, we just our eyes is designed to see the radiation between the red light and the purple light or violet light, which are the seven spectrum colors. But actually, there are more spectra beneath the red and above the violet. Okay, so we have the X-ray, the radio waves, microwaves, gamma rays, ultraviolet, infrared, a lot of radiations. But actually, most of this radiation is plugged or trapped of the atmosphere because the atmosphere already work as a shield that protects the Earth from these harmful radiations. So these radiations actually could send a kind of waves, or they could okay give us a hint about how this celestial bodies or these uh, objects in the space look like. But unfortunately, we can't receive these radiations on the Earth because of the atmosphere. That's what makes okay scientists think that if they are able to make a telescope in space, but in this case, this telescope will not be optical. That means it will not depend on light or forming images by light. It actually depends on receiving waves of different or other radiations. Okay, so as you can see here guys, in this picture, okay, could represent that our visible light is very small portion of the total okay radiations that are emitted from stars or from the sun. So we just able to see this, and that the part which is not harmful for our body, but actually this we could find a lot of radiations. So we have infrared, microwave, radio wave. We could find that it's the wave with the longest wavelength, while the gamma ray it is the wave with the shortest wavelength and the highest frequency. So like this, we could find the different waves. They have different wavelengths and different frequencies. Okay. So scientists like this, okay, they start to make the non-optical telescopes. Non-optical telescope means telescope that will not depend on the visible light, but will depend on the other radiations with different wavelengths and frequencies, okay, to obtain information about the different objects in the space, okay. So, like this case, science already they made the radio telescope. Okay, for example, radio telescope that a telescope detect radio waves, and because the radio waves are too long or their wavelength is longer, okay, than the optical wavelengths or the light wavelengths, so radio telescope, okay, could provide or the radio telescope itself will be very large, okay, and that could provide different okay details that what we could receive from the optical. So actually, science doesn't make only radio telescope. They make a telescopes, okay, for infrared, X-ray, gamma rays. So that means they make telescope that could receive different radiations, not only the radio telescopes. So why they made different telescopes for different radiations? Because actually each radiation could give a different image or different information about how these objects in the space look like. So by gathering the information of these different telescopes, we could get a more clear okay, imagination and a more clear uh, facts about what these objects in the space, especially the farthest objects in other galaxies, okay, how they look like. Then here we find that as the radio wave has certain frequencies, okay, like the radio channels that you receive in your home, okay, that make science has an idea that if they are able to connect all these radio telescopes together, so astronomers can get more details, and more images of universe by linking radio telescopes which are already in different places in the space. So like this, we could make a whole big multi-dimensional image, okay, for the different objects, okay, on different directions. Then here, like this guy, we said that also because most of the electromagnetic waves are blocked, so scientists start to make a lot of telescopes associated for ultraviolet, infrared, and gamma rays, and so on, and put all these okay telescopes in the space that's try to discover more and more about the space and how it's look like. So like this guys, okay, we know the history of telescopes, different types of telescopes, and how we or science over time they start to develop telescope or making different ideas that's trying to find more and more about the space. At the end of our lesson, please study this part very well and read it carefully from your textbook. So and then answer the section review. We are gonna discuss it next time, inshallah. Thank you guys and goodbye.